Okay, let's get the PowerPoint back up. And we'll start from this slide. All right, I can't think of any major announcements right now. I think my office hours are almost back to normal. On Mondays and Wednesdays, today and Wednesdays, they're 3:15 to 5:15. Tuesdays and Thursdays, 1:15 to 3:15. Friday, 7:45 to 11:45 on the Birmingham campus. With one major exception, today I've got to take care of a situation with my former vehicle. It died completely. It's down here at Pet Boys parking lot, and they're going to haul it off today, and I have to be down there to exchange, give them the title and that kind of stuff. So there will be part of that probably right after 3:30ish or so that I'll need to be off campus, but it shouldn't be more than 15 minutes, I'm hoping, because it's close, and I'm hoping that'll get taken care of. So I will be back on campus. I'll probably stay a little late today to make up that time. All right. Any questions on anything we've done so far? Okay. Now, I believe we did this problem before. Okay? If you had recalled everything we said before, what do we do? Or if you don't recall that, how would you approach that problem? Factor it. Say again? Okay. Okay, I heard factor and I heard divide. Is that? Rewrite? Okay, how would you rewrite? Now, factoring, actually, the numerator is 2 times 2. Up there, this denominator down here is just x times y. There's not a lot to factor that. So what do you mean by rewriting?
4 over x and then times x.
Okay. She did 2 steps at once there. This is a division problem. Okay. It's a rational fraction. That's what they call it complex fraction. It's a rational expression involving 2 rational expressions. And how you could rewrite this is 4 over x, if I could write. Okay. If I could erase. Okay. Divided by, see that horizontal line is a division line, divided by 2 over xy. And then how do you divide fractional forms? You keep the first one, 4 over x, times the reciprocal, which is what was said. Say again? xy over 2. Exactly. Now what do you do? Yeah, divide out common factors. And I assume that's probably what you meant by factoring. I took out the x's. What else do we have? 2 will go into 2, 1, and 2 will go into 4 twice. And what is your answer? 2y. And that's L. Okay? Now, that's how the book did it also. I think. I can't read the next slide well. But, okay, so let me clear this out of the way so we can see the next slide. Okay? They say this is a simple division problem, exactly like we did. Rewrite that as 4 over x divided by 2 over xy, which is the same as 4 over x times reciprocal xy over 2. Now, notice here, folks, maybe back when you were doing numerical fractions, you might have put a times sign here. Now that we have variables and the times sign looks so much like an x, probably a good idea to use the center dot for your multiplication symbol, just to keep from confusing yourself. Then divide out common factors, 2's and x's, and that leaves us with simply 2y. Now let me show you, I may have mentioned this to you before, but the other way that you can do this problem. And then you can pay your money, and you've already done that, and take your choice of which one you want to do. The other way to approach these problems, in fact, this is about all of these problems, is to, let me take away that equal sign for now. Since you have division of two fractional forms, and since you're dealing with fractions, even though division you don't usually worry about common denominators, but in this case let's do. Let's look at the common denominators of all the denominators in this 4 over x and 2 over xy. What's the least common denominator between x and xy? xy. It has to be common to both. X is common to both, but xy is not common to this one. So the least common denominator is xy. And how, okay, and what do we do with that then? We multiply by that common denominator, xy over xy. Now, why can we get away with that? What's xy over xy? 1. And when can you divide by 1 or multiply by 1? Anytime you want to. It doesn't change the value at all. Now, in this case, notice that your x's will cancel out here, and both x and y cancels out there, and that leaves you with 4y over 2, which then you can divide out the 2 and leave you with 2y. Same answer either way. Just depends on which way you want to do. This is simply a division problem, real easy to divide, invert, and multiply. That one, real easy to multiply through by common denominators. Either way works, whichever you see best. All right, that was example 5. They don't show example 6, or 7, or 8, or 9, or 10, okay? Because they say that's the end of the slideshow, which, of course, we're not going to pay any attention to. So, let's go back and do example. They did the easy one for you and then didn't show you the others. So let's do the others. And they aren't hard either. This one has all numbers in it. Okay? 1/2 plus 3/4 divided by 5/6. I'm dyslexic today. Okay. 5/6 minus 3/8. Okay. And you have two choices again. Which way would you choose to do that problem? Does anyone think of the two choices? Or one choice? Okay, that will certainly work. Let's find the common denominator of all the denominators, both in the numerator and denominator. Common denominator between 2, 4, 6, and 8. Second? 24, okay? Because you see 2 will go into 24, 4 will go into 24, 6 will go into 24, and 8 will go into 24. So we're going to what do we do with it, though? Multiply numerator and denominator by 24. Now, take as many steps as it takes to do this. And of course, why can we do that? Because 24 over 24 is 1. And you don't change the value, you just change how it looks. Okay? Now, at this point, we're going to distribute, is one way you can look at it. 24 times 1/2 is what? 12. Plus, now, if you do 24 times 3/4, 4 will go into 24. 6 times 3 is 18. So you have an 18 there. Everybody see what we did? Yes? Okay. Now, distribute down here. Any questions? Yeah, okay. Okay. Down here, we're going to distribute here too. 24 times 5, 6. 6 will go into 24. 4 times 5 is 20. Okay. And Say again? 8 will go into 24. 3 times 3 is 9. Okay? And what does that leave us with? Numerator? 12. Say again? 12 plus 18? 30. Denominator? 11. Guess what? Not much you can do with that. 11 is a prime number. You can't factor out any common factors. Since the original problem was written as a fraction, then I would leave that as a fraction. I see no reason to change it to a mixed number. You can if you want to. That's perfectly fine. That would be 2 and 8/11. If you want to write it that way, fine. There's really no reason to. They left it as 30/11. Any questions on that? Now, the other way you could have done it if you wanted to was find the least common denominator here and add these two fractions. That will give you a fraction. Find the least common denominator here, subtract these two fractions, that gives you a fraction, and then divide like we did last time. That will work. I found this a little bit shorter, easier for me to see. However, if you see the other way better, go for it. It works. Just make sure you do all the steps right, okay? So that's example 6. Okay, I think we did that one last time, if I'm not mistaken. Okay? And? Name again? Chris. Okay. Love it. All right. We're on page 206. This is chapter 4, Rational Expressions. 4.4, more on rational expressions and complex fractions. Example 7 is where we're about to start now. If I can find my cursor to erase. All right. Here we have something fairly similar to the last one. Okay. Jalen? Okay. All right, good deal. We're on page 206, chapter 4, Rational Expressions, 4.4, more on rational expressions and complex fractions, example 7. Simplify this. 3 over x plus 2 over y divided by 5 over x minus 6 over y squared. Fairly similar to the last one, except these are not all numbers. We have some variables in here. So what would you suggest we do first? Again, we have two possibilities here. What would you choose to do? Common denominator of all your denominators in both the numerator and denominator. What would that common denominator be? xy squared, because x will go to xy squared, y will go to xy squared, x will go to xy squared, and y squared will go to xy. All of them will go into that. So what do we do with that least common denominator? Multiply both the numerator by xy squared and the denominator by xy squared and see what happens. Okay? And again, we're going to distribute. Xy squared times 3 over x, what would go out? The x's, and that leaves you 3y squared. Okay, right? So you get a 3y squared in the first one. Okay, how about in this? Any questions? Okay, the second one, you distribute this over here, what goes out? 1y does. What does that leave you with? 2xy, because one of those y's goes out, and you're left with a plus 2xy. Fantastic. And in the denominator, when you distribute this across to here, what goes out? 5y squared. Perfect. Okay? 5y squared minus, what's your signs? 6x. 6s. Oh, no, okay. All right. Now what? Always look to see if you might be able to simplify. The only thing I can see that could possibly simplify was factoring out a y from the numerator. But since you can't factor a y out of the denominator, what's the point? You can't divide it out, so this form is just as good as if you had factored it out. That just is a different way of writing it, okay? And let's see which one the book chose to go with. They did choose to factor. Well, they said or. The first way they did it, they didn't factor, but the second way, solution B, they said either one of those answers is fine. To me, that's just as simple, so I'm fine with that. Now, that's interesting because now JT's here, right? No, I'm sorry. Help me. Second? Sheffield, right. Okay. I'm trying to there, Jay. Okay. That's the first part, right. Okay. Now, what I was going to say, I'm pretty sure that, I know I asked them to, and I think I saw that they had done it. They did allow you, those of you who have advanced WebAssign or whatever they call it, that they gave you a code that you can use, and you can use anything in that, right? Well, if you choose to use that, and frankly, those, they have tutorials, they have videos, they have several things like that that I think would be very useful, and I suggest you take advantage of them, okay? Okay. To Marcus? Is that right? Yeah. Okay. All right. I highly recommend you use it. You paid for it, use it, okay? I'm not going to make any assignments in it, and here's why. This problem is an excellent example. I don't know if I had assigned this problem, which of those two possible answers that I just described, either written just like this, or factoring out the y and said y times 3y plus 2x in the numerator, and then the denominator stays the same, 5 over 5y squared minus 6x, they would have only recognized one of those as the correct answer. Both of them are equally correct. And if I had made an assignment and you had that to do, and you wrote down one of these and the other one was the one they were looking for, then it was said wrong and would have counted you off for it when you got it absolutely correct. And then I have to go in there and override it and figure out a way to change your grade in it and do all that kind of stuff. And it's just a pain in the neck for you and for me. So that's why I tend not to use it. But it's a good tool. It's a good thing. You can access that. You've got your access code. You can go in there and use the tutorials, practice on the problems. Don't let them frustrate you. If you can't figure out why they're telling you it's the wrong answer, bring it to class. I'll be glad to work on it there. But I'm not going to go through all the hassle of explaining why, well, or just trying to correct their error, because frankly, that's what I feel like it is. All right, that's my little soapbox. I'll get off of it now. Any questions on this one? Okay, that's example 7. Let's move on to example 8. And by the way, every one of these examples has a classroom example right next to it in the margin. Good thing to go home or go to the library, go to another empty classroom somewhere and do the classroom examples as soon as you can after class is over with and you don't have another class, just so you get an opportunity to nail these concepts down while it's fresh on your mind. Here's the next one. 1 over x plus 1 over y over 2. Is that a rational, is that a complex fraction the way they call has rational forms in the numerator. You don't have necessarily a rational form in the denominator, but you can make it a rational form, right? How would you make that a rational expression? Divide by 1. So you can make it that if you choose. So how would you go about simplifying that rational expression? What did we do before? Say again? Multiply by 1? Is that what? Yeah, well, that's truly what we're doing. How do you want to multiply by 1? Common denominator? What would that be? XY. And then what do you do with that XY? Multiply by the numerator. Ooh, what am I doing here? Okay. Multiply the numerator by XY, but then you also have to multiply the denominator by XY. Okay? Now, we distribute in the numerator. XY times 1 over X would give you Y. Why not? Okay? So that gives you a Y plus X over 2XY. You sort of messed up the denominator some, but you did simplify the numerator. Anything you can do with that? No, absolutely not. Well, there are a couple things you could do, but they don't make it any simpler. So that is as good a form. Yeah, X plus Y over 2XY. I glanced at it and saw the answer for example 9 said, no, that's not right. Okay, that's a different problem. Any questions on that one? So even if you don't have a denominator in the denominator, still go through the same procedures. Okay? This one's going to reverse the trend. And this time we'll put a -3 on top, and on the bottom, a 2 over X minus 3 over Y. Okay, what would you suggest we do here? Okay, what's your common denominator in all the denominators? XY again. And what do you do with it? Multiply numerator and the denominator by XY. You can't multiply the numerator on the left and the or on the right, and the denominator on the left, just because it's going to make it look better later. What does the numerator become? -3XY. That's why I wrote it there. All right, that denominator we're going to distribute. And what does the first give you? 2Y. And the second? Minus 3x. Don't forget your signs, okay? Minus 3x. Anything you can do to simplify that? No, there's nothing you can do to simplify it. So -3xy over 2y minus 3x. Very good. And now for a little weird one. Okay. All right. Whoa. All right. 1 minus n over 1 minus 1 over n. How about a weird little problem? What would you do with something like this? And don't pun it, okay? Okay, you do, but let's separate out this part. Here is your complex fraction. Let's deal with this by finding common denominator. And then when we've worked with this, then go back and do 1 minus whatever that is. Okay? So, let's deal with that first one. Just that. And what is the least common denominator of that? N. Okay, and what do we do with the n? Multiply it by numerator and denominator. All right. Chuck. Yeah. All right. End up being pretty good attendance today. Okay. We're on the last example in Chapter 4, Section 4.4. Chapter 4, Rational Expressions. 4.4, more on rational expressions and complex fractions. And example 10 is the one we're working now on page 208. So what does that, just so we don't forget it, write down the 1 minus, okay? And what does the numerator give us? In numerator. N squared, perfect. Divided by n minus 1. Very good, okay? Now, you have a regular old fractional expression. So what I'm going to do is erase these grouping symbols, because you really don't need it. Don't need that long a line there either. Okay? How would you do something like that? This is no longer a complex fraction. That was a complex fraction part. What will you do with this? Help me out. Say again?
Back to the n squared.
You could, but that's not going to help you any. This is what we did back in section 4.3, I think it was, wasn't it? Maybe 4.2, somewhere in there. This is subtraction of rational expressions. How do we do that? Just because we're through with that section doesn't mean we're through with the concept. When you have fractional forms and you're trying to do addition or subtraction, what do you have to get? Common denominator. And what would it be in this case? N minus 1. Okay? So you need the numerator to be over the first term to be over n minus 1. The second term's already over n minus 1. So that's already an n squared over n minus 1. That's already in fine form. What do you need to do to get your numerator here? What did you do to this denominator? What was your denominator here to begin with? 1. And what did you do to it to get n minus 1? Multiply by n minus 1. So what had you better do to the numerator? Multiply by n minus 1. And guess what? What is n minus 1 over n minus 1? 1. That's exactly what we had to begin with. So this is indeed right. So where do we go from here? You what? No, that gets you back to here. What we got is least common denominator. You got your common denominators now. So keep your denominator. I'm going to move up here with it. Keep the denominator n minus 1 and subtract your numerator. That'd be n minus 1 minus n squared. Right? Oh, I didn't. Yeah, no, I did it right. N minus 1 minus n squared. There's your numerator. Now, is there anything you can do with that? Okay, did I hear crossing something out? Let's not do any crossing yet. What I want to do is write this in more standard form, decreasing order of my powers. And I also don't like having a minus sign. That's going to be my leading term is negative. So what I'm going to do, I'm going to do two things at once if it's okay. Okay? First thing I'm going to do is factor out a minus 1. So let me just put a minus in front. Okay? Now that's going to make my numerator, everything in it change signs. Okay? So that'll be an n squared because it was a minus n squared. That'll make it a minus n because it was a plus n. And then it's going to be a plus 1 because it was a minus 1. Okay? And then divide that by n minus 1. Now, the reason I did that, I want to see if there's any way I can factor that numerator. And what do you think? I thought maybe I could, but guess what? I can't. I don't think I can. It would have to be n minus 1 times n minus 1, and that would have a negative 2n in the middle. So all this that I just did was not worth anything. It didn't simplify the problem at all. It's another way to write it, but this form is perfectly fine. So that is a perfectly good answer. That's a perfectly good answer. You could have not taken out the minus 1 and made it minus n squared plus n minus 1 over n minus 1. You could write it several different ways, but none of them are any better than the others. So let's see how the book left it. They wrote it both the middle way there, the first way we wrote it, or they wrote it the second way, the third way, the one beneath that. They didn't factor out a minus sign. Okay? Either one of those answers would be fine. Even the top answer would be fine. But if we're doing WebAssign, it would have only wanted one of them, and you just didn't know which one it was. All right. That finishes 4.4. Any questions so far? Okay. There's a concept quiz, 7 true-false questions. Don't expect to see many true-false questions on a test, but read through those, see if you can figure out what they're talking about. Number 8 is not true-false. It's a arranging problem. So I would definitely do that. You're not going to see one like that on the test either, but that's good for the concepts. And then the problem set. Do any of the odds 1 through 39? I mean, there's a bunch of those. Now, I wouldn't just do 1 or 2. I'd say do 1 or 2 of the easier ones, 1 or 2 of the little more complicated. Just go through there, pick through several of them. If any random ones you get, including some of the harder ones, you figure out how to do it, say, okay, I got that. Then move on to any of the odds 41 through 63. Those are the ones like we were just doing, complex fractions. Any questions? Okay, good deal. Let's then go on to all right. .5. This is the last section that we have of just strictly polynomials. Rational expression. Well, I'm sorry. Forget that. I was thinking my other class. Okay. All right. Let's pick up the slideshow at the beginning of 4.5. And before we get near the end, last time I did pass out a quiz for Chapter 4. If any of you did not get that quiz, be sure you get it before you leave today. I did give you one, right? Okay, yeah, because I've already got one on back in. Okay, good deal. So if you weren't here Wednesday to pick up a quiz, get it before you leave today. All right, we're continuing with rational expressions. This time we're going to be dividing polynomials, okay? And we're going to do it 2 ways. One is what they call long division of polynomials. And then for certain polynomials, not all, but for certain ones, we can actually use a shorter method called synthetic division. Okay, the reason I was getting crossed up, my pre-calculus algebra class just finished doing this, and I was thinking, well, but we already done that. Then I realized it was the other class. Okay? Now, though I don't think we've done this in this class, I think you've done it in other things. When you are dividing powers, okay? Same base, different powers, or even if they're the same power, what you do is keep the base, subtract the powers, the numerator's power minus the denominator's power, the exponents, right? Now, you remember that? That'd be like, we've done it, like x cubed over x. What would that be? X squared, because x cubed is x times x times x, and x is just x. Divide out one of the x's, and that leaves you x squared, right? Okay? Along with our knowledge of dividing integers, which we know how to do those, then we can use those two concepts to divide monomials. Okay? So what would you do with one like this? And frankly, I like to start with the numerical part. What would 12 divided by 3 give you? 4. Okay, you got that part. And then the next part. X cubed divided by x. X squared. How did I know that? Okay. All right, let's go to this one. Ooh. First, on this one, I would deal with the signs. What sign's your answer going to be? Negative, because count your number of negative signs. If it's an odd number, it's going to be negative. And it was 1. Okay, then do the numerical part. 9. Then do the variable part. X to the third. Y to the third. Excellent. Way to go. Okay, everybody see that? All right. Monomials are pretty simple to do. Deal with the signs, deal with the numerical part. If you have a numerical part, then deal with the powers or the exponential parts. Now, we've also done this in the very last section, in sections before that. If you are adding fractional forms, okay, a over b plus c over b, if you have the same denominators, we just did this, and even if you didn't have it, when you get the common denominators, put it all over the common denominators, add the numerators, or subtract the numerators. If you have common denominators, keep the denominator, add or subtract the numerators. Right? We just did that. Now, this is the basis for adding and subtracting rational expressions. Now, the A's, B's, and C's are not numbers. They are just letters. They can be expressions, okay? Polynomials or whatever, okay? So here we have several things going on at once. So what in the world are we going to do next? In these same equalities, A plus B over C, you can go backwards with it and make that A over C plus B over C, right? Just because you did it one way, you can do it the other way. Same thing with the second one. A minus C over B is the same as A over B minus C over B. You just separate them, okay? As long as you got that common denominator, okay? So, if you have a form like this, what we do is first put this over the denominator plus this under the denominator, just like we did up here, right? And in the first one, what does that give you? Put the first term over the denominator, that would be 18x cubed over 6x plus 24x squared over 6x. Now let's simplify the first one. Numerically, 3x squared plus 4x. Perfect. Way to go. How about this one? Excellent. Minus. Excellent. Okay. Then on the first one, what would you do? 7. Say again? 7xy. Perfect. Minus 11. X squared, y squared. Excellent. Way to go. Everybody see how that works? Love having monomials in the denominators. Makes the whole process really easy. When you start having binomials and trinomials in the denominator, it gets a little more complicated. When you have monomials in the denominator, it's really easy to do, most of the time. Okay? So, to divide a polynomial by a monomial, we divide each term of the polynomial by the monomial. That's what you just did. As with any skills, once you feel comfortable with the process, you may then want to perform some of the steps mentally, which I think you can do here. What would you do? Okay, yeah, skip that step and go straight to this divided by that. 5 x squared y to the fourth plus 72 divided by 8. Second? 9 x cubed y to the 6th. Very good. So you don't have to write out every term unless you want to. There's nothing wrong with writing out every step. But if you can see how to do it without it, you don't have to. How about that one? Whoa. Negative 4 AB. Got it? Watch those signs. Minus divided by minus is plus. 5 A squared B to the third. Way to go. Y'all got this down pat, right? Okay, any questions? No. If we're going too fast, ask me. Don't let me zoom past. Is there any step here you don't see? And like I say, if you need to do every step, write every step. It doesn't hurt. There's no penalty for being careful. Okay, be careful. Any questions on this? Any part of that? I'll go back a slide or two. Any questions? Okay. Practice. Okay. Now. Now, if you have a form like this, 3x squared plus 11x minus 4 over x plus 4, what would be your first inclination? If you can, what's the F word? Factor the numerator and see if x plus 4 is a factor. Okay? In fact, I would almost cheat with it and say, let's see if x plus 4 is a factor. If x plus 4 might be a factor here, what would have to be this other factor? It's so easy to do when everything's done for you. Let's back off here. Yuck. Here's something. Okay? Let's go back to that one. 3x squared. Whoops. Get my pen back. Okay. Where was it? There it is. 3x squared plus 11x minus 4 over x plus 4. Okay? Now, I can't look at that numerator and say, oh, I know that's factorable. I can hope it is, but I don't know that for sure. So let's see if it is. If it's factorable, it's not going to do us any good unless one of those factors is going to be x plus 4. So which one you want it to be, first or second? I don't care. First, okay, put x plus 4 here. Now, if I had been factoring the way I used to do, I'd say, what's the only possible factorization of 3x squared? What's the only possible factorization of 3x squared? That's how we used to factor, right? Long time ago. Huh? That would be it. 3x times x. Well, there's our x, so the other one would have to be a 3x, right? Okay, what sign would it have to have here? Minus, because we already got a plus. The last sign's minus, so these have to be different. What's that? can't hear you. Something about division I can't hear well. No, this isn't synthetic division. No, this is factoring. Okay, what we've already done. What would have to be this last number here? Once you got the x's done and the signs done, then you see what all the possible factorizations for 4. Well, there's several. But we want one of those to be a plus 4, so this one would have to be a 1. Okay. Now let's see if indeed that is a correct factorization. No guarantee, but let's see if it is. How do you check it? X times 3x is 3x squared. That's so far so good. Minus x plus 12x would be plus 11x. Yes. And negative 4. Yes, that does factor. And then here's one way to do division. If you can factor the numerator and there's common factors, there we go. Okay? Now that was a little long and hard, and maybe not that hard, but just a little bit difficult. Let's try this by division. Okay, I don't know. Give me a number, any number. Make up a number.
2.
Say again?
2.
2 divided by, give me another number.
4.
4, okay? And if I were doing that division, wanted to get a fractional answer, what would I do? Drop this and do 4 and the 2. Actually, I would reduce it first, and then you would start dividing, right? And that would give you 0.5, right? Yeah, well, we knew that. 2/4 is 1/2, and that's 0.5, okay? Well, we're going to do the same type of thing down here, okay? Only with, in fact, let me back off. I'm going to give you the example. Let's say we had 3,114 divided by 14. How would we divide that? I should have done this rather than letting you give me numbers. You would divide the 14 into 3,114, wouldn't you? Okay? And how would you do that? 14 into 31. Notice here, when you're adding, when you're subtracting, and when you're multiplying, you always start at the right and work your way left, right? Okay? In division, you start at the left and work your way right. Okay, yeah, we start with 14 into 31. And what does that give us? How many times? Did someone say 14 into 31? It's been a long time since. 2 times, very good. And then we did what? It's been a long time since you did long division, wasn't it? What you did next? You what? Yeah, multiply. 2 times 14 is 28. Very good. Then what? Subtract. And what does that give you? 3. And then you do what? Bring down to 1. Very good. Then 14 into 31. 2 again. And then you multiply. Still gives you 28. And then you subtract and still gives you 30. Bring down to 4. And then you divide again, 14 into 34. Still 2, room 222, okay? And what do you have? 28. This time a remainder of 6, okay? And you could either write that as remainder 6, or you could write it as plus 6 over 14, which you could reduce to 3 over 7, right? Remainder over the denominator, divisor, right? Which is your denominator. Okay? Yeah, remember how we did this? Oh, that was so much fun back before we had calculators. Calculators make it so boring now. But back then it was fun, right? Yes, okay. Let's do the same thing with polynomials. Let's do what's in the denominator x plus 4 outside the house, and inside the house we put 3x squared plus 11x minus 4. Okay? What's that? Yeah, it's a quadratic form, but you can put any kind of polynomial in there. Whatever's in the numerator goes inside the house. Whatever your divisor is, that goes outside the house. Okay? Your quotient goes outside the house. Now, a couple things you have to worry about with polynomials you didn't have to worry about with numbers. Number one, you could have written this as 4 plus x, right? You wouldn't have changed anything. It just, you wrote it differently. And you could have written this as 11x minus 4 plus 3x squared, right? But we don't want to. When we're doing division, make sure you have them in standard form. Decreasing order of your powers. 1, 0, 2, 1, 0. Be sure they're in that form. The other thing we have to be careful for is that we haven't skipped any terms. If this had been an x cubed up here, and you didn't have an x squared term, you would have had to say 3x cubed plus 0x squared plus 11x minus 4. You have to count for every power of x. This one was fine. Now, the rest of it goes just like we did long division. What's the first thing we do? And we start on the left and divide x into 3x squared. How many times will that go? So again, x into 3x squared. Now you're dividing, not subtracting. 3x. Perfect. And then what's the next thing we did? Multiply. 3x times x is 3x squared. It better be. That's how we did it. And then 3x times the plus 4 would be 3x times plus 4 is plus 12x. Keep a sign with it. Okay? Now, the next thing we did was, up here was subtract, right? Now you've got signed numbers. So how I suggest that you subtract signed numbers is exactly what the rules are. Change the second number, change the signs of the lower one, and add. That makes it so much easier. So let's change this to a minus and change that one to a minus. Okay? Easy for me to do with my little magic pen. And add. These add to 0, which is exactly what we wanted it to. What do these add to? Negative x. And bring down the minus 4. Now you do x into negative x. How many times will that go? X into negative x. Whoa! X into negative x. We're dividing. Okay, wait. Okay, let's start it. Let's do the coefficients. What's your coefficient of x? 1. What's the coefficient of negative x? Negative 1. How many times will 1 go in the negative 1? Negative 1 time. Right? Why? Okay. Then you do x into x. Well, that will go 1 time. So you have a negative 1. Okay? Plus will go into minus, a minus time. 1 will go into 1, 1. X will go into x1. So it's minus 1. And then what do we do next? What do we do up here? Multiply. Negative 1 times x is negative x. And negative 1 times 4 is negative 4. And then when you subtract or change signs and add, you get a remainder of 0, which means it goes into an exact number of times. So what have you done? You just divided. And you got 3x plus 1. What do we get? Minus 1. What do we get up there? 3x minus 1. Got the same answer. You can either do it by factoring, if you can factor, or you can do it by division, long division. Well, guess what, team? If you couldn't have factored that, the only thing you can do is long division. Okay? Or quadratic formula or something like that. Okay? So, I've jumped a little bit ahead there. Oh, no, I didn't. That's exactly what they did next. Okay? Right here. Okay? We first factored it, just like they did, and got 3x minus 1. And we can get the same result by using division process, similar to long division in arithmetic. Put the divisor in as the denominator as the divisor, and the numerator as the dividend. Okay? Put it in the house here, and then do 3x, and x will go into 3x squared, 3x times. Then you multiply, 3x times x is 3x squared, 3x times 4 is plus 12x. So, then you subtract. Now, I like to change signs and add. They just say you subtract. And you get a negative x, okay? If you change signs and add, I find it a little easier to do. It says, remember to add the opposite. So change signs and add. That's exactly what they're saying. That gives you a negative x. Bring down the minus 4, just like you brought down the other numbers before. And then do x will go into negative x, negative 1 times. Negative 1 times x, negative 1 times 4, negative 4. This time you have no remainder. That means you did factor it completely. Your answer was 3x minus 1. Okay. Do we have time to do this one? Okay, let's try. Oh, I thought you said yes. Oh, man, I thought someone said yes. Let's not lose a minute here. Okay. All right. We will start next time with example 1. Okay? Now, I think, just based on what we did, you can, you could do any of the odds, 1, 3, 5, 7, any of the odds 1 through 9. Okay? And hold off on the rest of them. We'll do those next time. Okay. All right. Any questions? What's the old know about? He said, I let him go too early. Oh, no. 2 minutes early. I cheated you out of 2 minutes of your tuition dollar. Oh, no. We're going to write him up. Yes. Okay. All right. Good deal. Have a good...
I get that quiz.
Yes. If you didn't get a quiz, be sure you stop by and pick it up before you leave. All right. Good deal. Thank you. All right, you got 1 back. 2 back now. Okay. All right. Let me find them. Somewhere back here. Nope, not quite. All right, quiz 2. Okay, you got to turn it in. 3. Thank you. Anyone else need quiz 2? Thank you. Huh? Finish the test. Quiz 2. Okay. Anyone else need quiz 2? You got it. Okay.
Can I take my test?
What's that?
I take my test Wednesday. I gotta go to work.
Okay, yeah. You mean after class on Wednesday?
Yes, sir.
Yeah, okay, sure. Thank you.
Because I've been trying to take off, and I've been, he's keeping me busy.
All right, good deal. So you're going to finish your test now. Have you started it?
I only have like 4 questions.
So you have to find it. Set, right? Okay. There you go. Now, I have another class coming up in here, so... Huh? Yeah, but I'll be teaching a class that'll be sort of loud, won't it? If you want to go back to that office, you can. That'll be a little quieter. Huh? Yeah, that'll be fine. Let me go shut this down. I've been recording all this.